So for this problem, what we can do is take the denominator and just factor it. So take the denominator and factor it into, just factor out an x, and then the remainder will be x squared minus 6x plus 9. Now we can factor this to get x minus 3 squared. Now what we can do is do partial fractions. So what do we do for that? Well, the first thing is just have three variables, a, b, and c, and since we have x times this, so the first variable can be x, right, and the second will be x minus 3, and the final variable will be x minus 3 squared. So now we can multiply both sides by this denominator, so multiply by that, multiply by that. So this cancels, right, so we're left with that. And then this will be on the numerator of every single variable, and we have the denominator. And as you notice, a lot of stuff cancels, right? Because right here, x's cancel. Right here, x minus 3 cancels one of these. And over here, x minus 3 squared cancels on both the top and the bottom. So we get a times this, b x times x minus 3, and then c times x. So now since we have this equation, what we can do is plug in any number we want, but that number should make something go to 0, so we can solve for one of the other variables. So in this case, I chose x equals 0. So what does that do? Well, right here, if I plug in 0, what happens? 0 times c is just 0, so that goes away. If I plug in 0 right here, what happens? Well, this entire expression goes away, right? Because anything multiplied by 0 becomes 0. Finally, over here, if I plug in 0, it'll be negative 3 squared, so it will be 9a, right? And then if I plug in 0 right here, it'll be 0, so negative 3x squared will go away. If I plug in 0 here, 8x will go away, and then we'll only be left with 9. So it'll be 9 equals 9a, okay? And so we divide each side by 9, and then we get 1 equals a. So now we have one of the variables, but we still need b and c. So we can plug in 1, right? So originally it was like this. So we can plug in 1 now for a. So now since we have that, we can solve for something else. So in this case, I chose x equals 3. So what will that do? Well, that will make this 3c, right? This will make this 0 multiplied by 0. Anything is just 0. Once again, here, 3 minus 3 is 0, so this goes away. So we're left with 3c. If we plug in 3 here, what do we get? We get 6. So then what happens is we can divide both sides by 3, and we'll get 6 divided by 3 is equal to 2. So we get 2 is equal to c. So now since we have that, we can plug in 2 for this equation, right? So originally it was cx, right? Now since we know c is 2, it'll be 2x. So the final number we can plug in is x equals 1. Because what will that do? That will help us get b. So for example here, 1 minus 3 is negative 2. Negative 2 squared is 4. Over here, b times 1 is just b. 1 minus 3 is negative 2. Negative 2b. And then 1 times 2 is 2 right here. And then if you plug in 1 for this expression, you get 14. So now since we have all of that, we can solve for b. So 4 plus 2 is equal to 6. We have negative 2b plus 6. Minus 6 on each side. So we get 8 equals negative 2b divided by negative 2 is equal to negative 4b. Now we have all the original expression, but we also just found every single variable. So we plug in all the variables. So for a it was 1, for b is negative 4, and for c it was 2. So now we can take the integral of all of these. So for that, what can we do? Well, we can take the integral of all of these separately. So for 1 over x, remember that it's the same as ln over absolute value of x. For this one, what we can do is same thing. We can pull out the negative 4, and then the other thing we can do is u substitution, right? Because u is equal to x minus 3. The derivative is just dx. So it would be ln of u, and then just plug u back in. So we get negative 4 ln x minus 3. The final thing is over here. So we do u substitution again. U is equal to x minus 3. We can pull out the 2, so it'll be 1 over u squared. So u is equal to x minus 3. right? But we can't plug it in yet because we still need to take the integral of it. So what will we do? Well, to make the denominator go into the numerator, we can make it negative, the negative exponent, right? So u squared, we can make it u to the negative 2. And now what we can do is actually take the integral. So what we'll do is we'll add 1, right? So when we add 1, it'll become negative 1. And then it'll be negative 1 multiplied by the inverse of negative 1, which is still negative 1, right? So we can just multiply it by negative 1 or divide by negative 1, because we'll get the same answer either way. So now what we can do is have negative 1, right? So since this is u to the negative 1, we can bring it to the denominator, so it'll be just u to the 1, so we can get rid of the 1. The negative 1, right, it'll make it negative, so it'll be negative 1 over u, right? Because remember that since it's u to the negative 1, when we bring it to the denominator, there's still a 1 at the top. So it'll be negative 1 over u. Remember the 2. So now since we have all of that, we can multiply across, so it'll be negative 2. Remember that we can't keep the u as just u. Since we did a substitution, we have to plug x minus 3 back in. So we get the original answer, and then we have the addition of negative 2 over x minus 3. And don't forget plus c, because that's an easy way to lose points. So I hope all of that helped, and thanks for watching.